Hello all and welcome back to the show. Today's topic is called percent composition. Percent composition is actually something pretty easy to calculate, and it's a really good follow-up after learning about formula mass. By now you're all probably good at calculating formula masses. This follows it directly. It's actually quite simple. And this applies to other things in daily life, as you'll hopefully soon see. Let's start off with something that's kind of an analogy to calculating the percent composition of a compound. Here's a silly question. What percent of students in my class are left-handed or is left-handed? How would we go about answering that? Well, first thing I would do is I would count up the total number of students in my class. So let's say there were 22 students in my class. And then I'd say, okay, raise your left hand if you are in fact a lefty. And I would find that there are 3 of those students that are left-handed. So what percentage of students in this class are left-handed? That calculation is actually quite simple. We'll take 3, which is the number of lefties. We'll divide it by the total number of students, which is 22. And we'll multiply by 100. And we'll do that here in our handy-dandy calculator. Good morning, calculator. 3 divided by 22 times 100 gives us 13.636363%. I'm just going to round that to 64%. And there we go. So I will say that approximately 13.64% of my students are left-handed. And there you go. That's how a percentage is calculated. And a percentage for anything is calculated in pretty much this exact same way. Whoops, wrong word. You will always do the part whose percentage you're interested in divided by the total of whatever it is, and you multiply by the wonderful number 100. And boom, that's how you get the percentage. What we're going to do in this video today is show how to calculate the percent composition of a compound. Okay, compounds are made of elements, and so a percent composition for a compound is simply the percentage that each element contributes, I suppose, to that compound. Now, percent composition of a compound is always done by mass, okay, not by atoms, right? It would be fairly easy to sit there and count up the number of atoms and say, okay, well, there's 5 atoms here total. No, it doesn't work that way in chemistry. It must be done by mass. And I'm going to show you how to do that now. So you will need your calculator and you will need a periodic table. Speaking of the periodic table, if you don't have a print one, go to ptable.com. That's the web-based version of this periodic table. It'll have all the exact same masses and whatnot. ptable.com, P-T-A-B-L-E. All right, without any further ado, let's get in. Let's calculate the percent composition of potassium nitrate. Step 1, determine the formula mass, the mass of this whole compound. So we'll do that the same way that was shown in the last video. So I'm going to list all of the elements. I'm going to say we've got potassium, we've got nitrogen, and we have oxygen. There's 1 atom of potassium, 1 atom of nitrogen. See the invisible ones? Whoops, a little oopsie there. And then 3 atoms of oxygen. Now we will multiply those numbers by their masses on the periodic table rounded to 2 decimal places. Potassium comes in at 39.10. Nitrogen, 14.01. And oxygen's mass, you can probably guess that right now. Anybody want to take a guess? Yes, you back there. No, not 27. 16, correct. Yes, very good. There you go. 16.00. There's the decimal. And so let's do a little bit of math. 1 times 39.10, 39.10. 1 times 14.01. You know, I'm not sure about that one. Let me calculate that one. Okay, there it is. It is 14.01. And 3 times 16.00, 48.00. Great. Now we add all of these up for the formula mass of potassium nitrate. 48.00 plus 14.01 plus 39.10 equals, look at that. That's a cool looking number right there. And the total, oh, hey, wait, stop that. Here we go. 101.11 grams per mole. Great. Whew! So that took a few minutes, but that is definitely the very first step in calculating the formula mass for a compound. Now, what we want to do is determine the percentage of each of these elements. And how do we calculate that? Well, pretty much the same way we did in the previous example, using this silly little equation, the part divided by the total times 100. Down here at the bottom, that is the total mass of this compound. So for each element, we'll divide the total mass of each element by that number and multiply it by 100. And this column of numbers right here are the total masses of each element in this compound. So there's one atom of potassium weighing that much right there. I'm going to divide that by 101.11, and I'm going to multiply it by 100. I'm running out of room, so I'll show the rest of it down here lower on the page. Nitrogen's one atom weighs 14.01, so I'm going to divide that by 101.11, and I'm going to multiply that also by 100. And then oxygen, okay, now one atom of oxygen weighs 16.00, but there are 3 of them in this compound, so we have to go with this 48.00 as the total mass of the oxygen. And we'll divide that by the total mass of the compound and multiply it by 100. And so, let me come down here, make a little adjustment, and let's come up with our percentages. So for potassium, 39.10, put it on the camera here, if that helps, divided by 101.11 times 100 gives me 38.67%. There, I'm just going to round to 2 decimal places, a good rule of thumb. Let's see, for nitrogen, 14.01 divided by 101.11 times 100, a lot of ones today, gives us, let's see, 13.86%. And oxygen, there we go, oxygen, shoot, here we go, 48.00 divided by 101.11 times 100 equals 47.47%. And there you are. All of it is the answer. We now know that potassium nitrate, the compound, consists of roughly 38.67% potassium, 13.86% nitrogen, and 47.47% of potassium nitrate is made of oxygen. That's the percent composition of potassium nitrate. Again, as a general rule of thumb, although it's not a strict law, I'm rounding all of the answers to this to 2 decimal places, keeping kind of consistent with the number of decimal places and all the numbers here. It's not a perfect execution of the sig fig rules, but I think for now it's probably good enough. Let me show you one more example, and then that'll be that, because this is not terribly complicated. Let's go with our good friend calcium hydroxide. It's got parentheses. Figure an example with parentheses would never hurt. Camera's being funny today. It doesn't want to line up right. All right, here we go. I like this better. All right, so once again, total mass of, list the elements. Yes, we're going to get the total mass. Calcium, oxygen, and hydrogen. Yes, it's a polyatomic ion, but for this sort of mathematical analysis, break down the 2 elements, regard them separately. What do we got? We got 1 atom of calcium. What do we got for oxygen? 2 atoms of oxygen. That's right. Oxygen doesn't have a number immediately following it, yet it is inside parentheses, and the 2 on the outside doubles everything inside. So whereas oxygen has a 1 after it, the 2 outside means that there are 2 atoms of oxygen. Likewise, there are 2 atoms of hydrogen as well. Multiply each of these by their formula masses from the periodic table. Calcium, where are you? 40.08. Oxygen, everybody knows that. Hydrogen, 1.01. You'll soon remember that one if you don't already. Okay, calcium's total mass, 40.08. Oxygen's total mass, 32 point double goose egg. And hydrogen, 2.02. Let's get a total. What is the total? The 40.08 plus 32.00 plus 2.02. Calculating. Ooh! 74.1 grams per mole. Now, a little side note here, I didn't think about this. Yeah, the calculator says 74.1, but we're going to keep all of these masses to 2 decimal places. So yes, in this case, let's slap on that extra 0. And let's be good with units, grams per mole. That's always a great idea. Now, each of these, the percent for each element is calculated by dividing the mass of the element, total mass of the element, by the mass of the entire compound and multiplying by 100. So divide by 74.10 times 100. Divide by 74.10 times 100. Divide by 74.10 times 100. And let's see what it gets us. So calcium. So, nope, wrong one. Okay, technical difficulties. Put it on camera here. 40.08 divided by 74.10 times 100. Whoops, delete that. 2 decimal places, we're going to get 54.09%. Oxygen, 32.00 divided by 74.10 times 100. 43.18%. Hydrogen, 2.02 divided by 74.10 times 100 equals 2.73%. There we are. Now we know the percent composition of calcium hydroxide. There it is. Couple final notes. Number 1, yes, the percentages should all add up to 100 because that's how the percents work. Sometimes, though, because we're rounding some numbers from the periodic table, if you add these up and you get something like 99.98 or 99.99 or even 100.01 or something like that, you probably still did the question correctly. Let's see how these add up today. 54.09 plus 43.18 plus 2.73 equals, wow, exactly 100. That worked out rather nicely. So if you complete a percent composition and you feel like adding them up to 100, go right ahead. If you get something drastically different from 100, you know you made a mistake. However, if they all add up to 100, that's not a guarantee that you did the problem correctly. Because if you had a mistake in one of these masses here, right, let's say for calcium you wrote 30.08, you could still execute the rest of the problem correctly and come up with all percents that add up to 100. Okay? So if you wish to check your answer, do so, but be careful. If the percents do not add up to 100, you definitely made a mistake. But if your percents do add up to 100, well, that's not a guarantee that you didn't make a mistake. So be extra cautious with that. And also, once again, what I have here in the circle is the total answer. Percents. The percent symbol is the unit of measurement for percents. So for these, you do not need to put grams per mole. Well, that's it, folks. Make sure you do some practice. I don't think you're going to find this very challenging. Next week will be the time to get into these moles, and that's where things are going to start to get a little bit confusing and tricky and whatnot. That's all I have for you for now. If I think of something else, I'll add it later. Hand, which means have a nice day.